Hello. Um, I'm gonna introduce a technique from number theory related to intermediate 7.44 problem. 7.44, it's a problem of a book. And the idea we learn from this problem is like a technique to prove that b over a is an integer. So the idea is like this. In order to prove that b over a is an integer, we have to try to find integers c and d such that b over a is equal to d over c, and the greatest common divisor of a and c is 1. Okay, so as an example, we use problem 7.44, which says that prove that this fraction is an integer for all natural numbers, and the proof is like this. We use the fact that n choose r is an integer, so we use some combinatorics in this proof as well. Okay, so we can write this first. We can write the first one, this one, as 1 over 2n minus 1 times 2n minus 1 choose n, and we can also write this fraction as 1 over n times 2n minus 2 choose n minus 1. The reason why this is good is because n, so this n and this 2n minus 1 are they're relatively prime, so their greatest common divisor is 1. So how does that play in handy? Well, if we combine 1 and 2, we can notice that we can cross multiply and get that 2n minus 1 choose n times n is equal to 2n minus 1 times 2n minus 2 choose n minus 1. And because they are relatively prime, we can get that n divides 2n minus 2 choose n minus 1, and 2n minus 1 divides 2n minus 1 choose n. Hence, this proves the result from equation 1 or either equation 2. Well, so I kind of generalized this to make this idea, so I could use this as a technique to prove that a fraction is an integer, or a way of kind of shaping the proof. Okay, so in general, if we find integers c and d such that b over a is equal to d over c, we can cross multiply and find that bc is equal to ad, right? But then we also know that a and c are relatively prime, which gives us that a divides b, which is equivalent to b over a being an integer. So when we are kind of making these proofs, we try to think of these integers c and d such that these conditions are satisfied. Thank you for listening, and I hope this was very helpful. Bye.